In this class, we see about polymer nanocomposites. So polymer nanocomposites are class of new material with remarkable properties. So here the host polymer is taken as a polyaniline, and in that some type of nanoparticles are synthesized with physical, chemical, otherwise thermal method, so that nanoparticles are incorporated into a host polymer so that we can obtain a polymer nanocomposite. So it is a composite material that contains a polymer matrix and an inorganic dispersive phase that has at least one dimension. It is in a nanometric scale. So that is a nanoparticle. So polymer plus nanoparticle, it will produce a polymer nanocomposite. So compared to pure polymer and pure nanoparticle, the polymer nanocomposite material is a hybrid material that quality has been improved compared to pure material. So nanoparticle. Nanoparticle is a small particle that ranges between 1 to 100 nanometer in size. So why we refer a particle size is in between 1 to 100 nanometer means, so on that range of particles, so the property of that particle has been changes compared to a bulk material, so that the particle size, at least half of the particles in the number size distribution must measure 100 nanometer or below, then only the particle property has been improved compared that of a bulk material of same one. So most nanoparticles are made up of only a few hundred nanometers. So that for particular reason, 1 to 100 nanometer size particles property has been improved compared to that of a bulk material. So finally, we specify the particle is in the range 1 to 100 nanometer means their property has been improved compared to that of a bulk material. So that size of particle is called as a nanoparticle. So that technology is called as a nanotechnology. Nanocomposite. So if we take a heterogeneous or a hybrid material that are used to prepare a mixture of polymers with inorganic solids like any clays, otherwise a type of oxides, that in nanometric scale, that type of materials are incorporated into a host polymer so that we can produce a nanocomposites material. So that materials are synthesized with the help of a in situ growth, otherwise an ex situ growth. So most of the polymer nanocomposites samples are synthesized by using a in situ growth. So here the biopolymer and inorganic matrices are taken for the preparation of a nanocomposite material. Polymers. So monomers of a small molecules, so that have mostly organic material, so that join together with a similar molecules to form a very large number of molecules. So that type of molecules are called as a polymers. So in another way, so the chain type molecules are called as a polymers. So in that chain, more number of monomers are repeatedly formed. So finally, we got a polymers. So polymers are a class of synthetic substance composed of multiples of simpler units called monomers. So the repeated monomer unit is called as a polymer. Polymer chains with an unspecified number of monomeric units, polymer nanocomposites. So polymer nanocomposites are generally noted as a PNC. It consists of a polymer or copolymer that having a nanoparticles or nanofillers dispersed in a polymer matrix. So that nanofillers are metal oxides, clays, otherwise any material that in the range of nano. So that nanoparticles are incorporated into a polymer or copolymer. Finally, we get a composite material. That composite material are named as a polymer nanocomposite. So polymer nanoparticle matrices, where the nanoparticles are those with at least one dimension or less than 100 nanometer. Polymer nanoscience is the study and application of nanoscience to polymer material. Generally, polymers are divided into two categories. One is natural polymer, another one is a synthetic polymer. So the best known natural polymers are obtained from nature. It include starch, cellulose, polysaccharides, proteins and nucleic acid. So synthetic polymers are generated polymer. It is not occur in natural way. So these polymers are synthesized polymers. So that polymer is called as a synthetic polymer. So the examples of synthetic polymers are nylon, terylene, synthetic rubber, neoprene rubber and plastic. Intrinsically conducting polymers. The example of intrinsically conducting polymers are polypyrrole, polyacetylene, polythiophene, polyaniline. So above conducting polymers, polyaniline is more attention because we need a betterment of polyaniline. Polyaniline is important new material for the rapidly growing technology. The development of PANI-based electronic devices such as batteries, sensor, supercapacitor, erosion protection. Polyaniline is relatively hard to process compared to other conventional materials. Different forms of polyaniline. So polyaniline having a various forms. So first one is leucoemeraldine. So completely reduced form of aniline is called as a leucoemeraldine. It is a colorless. This type of material is an insulator. So then next one is emeraldine base. This is a partially oxidized form of aniline, not neutralized, blue in color. This is also an insulator. So next one is an emeraldine salt. It is a partially oxidized form, neutralized, green in color. It is a conductor. Next one is a completely oxidized form. It is called permigranulene. So it is purple in color and insulator.